listener production.
Hi, Simon Beaton joining you with this episode of The Briefing. 4 kilometres below the surface of the Pacific Ocean, right down in the black depths, scientists have discovered small clumps of rocks producing oxygen. Previously, we really only thought of living things such as plants or algae as making oxygen using energy from sunlight, really. So what's exciting about this discovery of dark oxygen is that it could revolutionise our understanding of how life on Earth emerged. These small, lumpy rock nodules consist of the same metals used in batteries and actually carry a charge that's similar to a AA battery. And apparently that's enough of a charge for it to split seawater into hydrogen and oxygen. Joining us to explain more about what's going on and what it could mean for the origin story of life on Earth is author and science communicator Lee Constable. Lee, how massive is the discovery of dark oxygen?
This discovery is massive. So it throws into question more things than it answers, I think, in terms of the origins of life on Earth being, perhaps more diverse than we thought before. It throws into question how we should interpret oxygen found elsewhere in the solar system and universe. It brings into question, how we're getting this mysterious oxygen source too.
Yeah, I mean, those are some pretty big claims there, life on Earth and everything. It is a natural phenomenon. Can you talk us through what's actually going on?
Yeah, so researchers actually who were doing this research on behalf of a mining company were looking at these nodules on the deep sea floor, 4 kilometres below the surface in the Pacific Ocean between Hawaii and Mexico. So there are these nodules about the size of a tennis ball way down deep on the seafloor. There's no light penetrating. It's deep, deep darkness. And they were doing this research because mining companies are interested in these nodules and in these areas for mining for minerals that are useful for lots of different electronics. But they wanted to do, obviously, the research to see what would be the potential impact of this mining on this ecosystem, because even beyond where light penetrates, there are amazing organisms. So what they did was they put down these devices, these benthic chambers. So they put them on the seafloor over these nodules and they kind of make a seal around them. And then what they can do is analyze the oxygen levels around these formations. And what they were doing that for is because you expect if you've got a thriving micro ecosystem down there that there would be breathing in and out, respiring, and you would expect the oxygen levels to go down as those microorganisms are respiring. They were just wondering how much it would go down. But instead, the oxygen levels rose and rose. And that was really strange. This international team, initially they didn't think, this is a deep sea source of mysterious oxygen. They thought, our sensors are, maybe not working. Maybe this is broken. They brought some of the nodules to the surface and they did the same thing again, and they kept finding the same thing. The oxygen levels would rise. So these nodules were actually producing oxygen.
Wow. So no one had anticipated that could happen?
No, not at all. So normally when we think of how oxygen might be produced, we think of photosynthesis, like in our plants and algae, where carbon dioxide and water are going into the plant, and then with energy from the sun, which is really important, that gets converted into glucose, sugar, and into, of course, the oxygen that they breathe out as opposed to us breathing it in. So without sunlight penetrating, there's no photosynthesis that could possibly be happening at these depths. And the oxygen down there in the deep sea floor is from deep sea currents that have brought this oxygen from the surface that's been absorbed into the ocean way down low, and you've got these amazing microorganisms subsisting off that. But that was potentially the only source before this research was published.
Yeah, right. So take us even further back then. Like, what is the current basic understanding of how life began on Earth?
Yeah, so we actually didn't have much free oxygen in our atmosphere, 3 billion plus years ago, which, of course, life as we know it relies on oxygen. And it was not until, around 3 billion years ago, we started to have cyanobacteria, these microorganisms that were able to produce oxygen in its earliest tiny amounts. But then, closer to 1.8 billion years ago, there was this huge explosion in the amount of oxygen in the atmosphere, because over time it had been building up, but then we had this explosion of photosynthesis that actually was able to increase the amount through the great oxidation event, which led to this explosion of species and multicellular organisms up to where oxygen levels were way higher at one point than they are now at 35%. And that led to even bigger and bigger animals than we have now.
So is this dark oxygen, is that happening or is it likely that it's happening at a large enough extent that it could potentially challenge that prior understanding of how life emerged?
Potentially. 70% of the world is actually ocean. So, if we have this source of oxygen, it really brings into question, not just that we know that photosynthesis has been hugely beneficial and has led to life on Earth and life that we have evolved from, but it does bring into question other places that oxygenation could have come from, and also that there are other ways that we can have oxygen explode onto the scenes, as we've seen in deep, deep past. So it really brings that into question. And the other thing that it brings into question is, what does that mean for when scientists are looking for life on other planets? How should we interpret the presence of oxygen when we see it in life on other planets? Could it have come through this other process rather than through photosynthesis? And so that's a big question. And there are even more big questions because we don't know the source of energy for this oxygen creation. We know how it's being created in terms of we've got H2O, water, in abundance down there, and it's actually being split into its hydrogen and oxygen parts, which is leading us to O2. But that takes energy.
Yeah, well, I was reading about this and I saw that those little metallic nodules are a lot of the similar sort of metals that are used in batteries, and that the charge that they were detecting was the equivalent of a AA battery. Are these metals also likely to be in moons within our solar system, like Europa, which have also water? Is there really a potential for this to mean that there is life elsewhere in our solar system?
So I wouldn't go that far right now. I think at the moment, Europa, like you said, or the moons of Saturn are really interesting, like Enceladus. I hope I'm saying that right, which actually has a lot of the building blocks of life as we know it. So that will definitely be something I'm sure astrobiologists are looking into right now and questioning. I think one of the most interesting things, though, before we can do those sorts of interpretations, is really figuring out this source of energy. Like you said, there is some electric charge that is being measured in these nodules. They're being called like deep sea batteries. But even that charge itself, I think, was less than the voltage that would actually theoretically be needed to split an H2O molecule to create oxygen.
Wow.
So we do know that there is this electric energy, but when they actually brought the nodules to the surface to measure them, while the oxygen did go up, eventually that declined again. And they're saying, well, that's probably because we've disconnected it from whatever this mysterious source of extra energy is, like a battery that runs out, it reduced again. So We have a lot of questions when it comes to where does this mysterious energy come from that allows this dark oxygen to be produced from splitting a water molecule. I'm excited. I love answers, but sometimes the questions are even more exciting. And there are so many questions right now. That's one of the big ones.
Absolutely. It's so fascinating. Thank you so much for joining us, Lee.
Thank you.
Author and science communicator Lee Constable there. Thanks for listening to this episode of The Briefing. That's it for now. Before you go, though, we'd love it if you could share this ep with someone you think might enjoy it. And if you want to keep up with our other content, you can check us out on Instagram at The Briefing Podcast and on TikTok and YouTube. Search Listener Newsroom. That's LISTNR. We'll be back in your feed tomorrow from 6 a.m. I'm Simon Beaton. See you next time.